So today, Aditya and Vallabh are going to walk us through the simulator that they have built. They were also going to walk us through the steps to get it installed on our system and then get it up and running. So those of you who are there, that is why I wanted all the second years to be there so that you can follow along, get that going, and then accordingly we can start building further on this, and we want to kind of improve upon the simulator as we progress. Okay, why don't you guys take it off?
Sir. Okay, so hello everyone. Today we'll be discussing about the KCS simulator project. What all progress is being done in this. We will discuss it briefly, and then after that we will show you how to install it on your host system. So let's get started. Next slide. Yeah. First, I will walk you through overview about what all goes in making a gazebo simulation. So the main goal of this project is to simulate the KCS with appropriate dynamics. Mostly we will be using the MMG dynamics. All of this will be done in Gazebo, and later we might want to control it using ROS. This might also be helpful for us if we consider the robobot competition, where we want to design our own boat and take it to the actual competition. So before that, it will be helpful if we make a simulation and test our autonomy architecture in this. So yes, that's one thing. So yeah, next slide. So what is Gazebo? So Gazebo is a simulation software in which physics of the vessel will be simulated and visualized. It has a distributed architecture. It has separate libraries for physics, for rendering, for user interface, and sensor data generation. It has two main executable programs for running the simulation. It has a server called a GZ server and a client GZ client. So the server is the main core of the Gazebo software. It is useful for simulating the physics, rendering, and sensor data generation. Whereas the GZ client provides a graphical user interface. It helps us to visualize what all is going into simulation, and it also helps us to interact with the simulation directly. These two, client and server, they communicate with each other using the Gazebo simulation library. Yeah, next. So these are the key components that go into a Gazebo simulation. So the world, model, and Gazebo plugins. These are the basic things that you need to have to simulate the things that you in a Gazebo in the Gazebo software. So world is a world description file. It has an extension .world. It contains all the elements in the simulation. It includes the robots, the lights, the sensors, and the static objects that are there in your simulation. So think of this like when we launch the Gazebo screen, what all you see visually in the screen, that all must be programmed in this .world file. And the second is the model. So it helps us to create standalone objects that can be used in our world file. It helps us to simplify it. Let's say like I want to spawn 10 KCS vessels in our simulations environment. So I will create just one instance. I will create a model file for KCS, and I will launch 10 instances in this .world file using a single line. So that's where this helps us to like it helps us to simplify our code. The model, they define a physical entity with dynamic, kinematic, and visual properties. So the visual, how it's going to look, what are its dynamics properties, means what will be its mass, its inertia, and all that must be described in this model file. Then the last one is the Gazebo plugin. This is the most important part if you want to programmatically alter your simulation. Let's say you want to apply force to your KCS vessel, then how will it behave? How will it move in the software? All that can be programmed using this plugin. So it is a piece of code that can be compiled as a shared library. Then after compiling this, it is written in C++. It has an extension .cc. After compiling it, we get the .so extension. It is a shared library, and after that, it can be inserted into our simulation and it helps us in programmatically alter the simulation. Yeah. So next, I think Vallabh will go on from here. He will explain what we have developed till now, and what are the folders, different folders, and what all is the content in them. Yes.
Yeah, so these are the main 5 folders that we have currently been looking at. So the first three folders are the ones that we will be actively working on for our KCS vessel. The latter two are related to the world, and they have been mainly borrowed from the VRX simulation, and we are currently not focusing on the latter two. We'll first focus on the first three. So the KCS description is about the how our KCS vessel should be looking and all of that. The USV Gazebo plugin, the third one, is actually the one that we have to modify thoroughly. So it will include everything related to the dynamics of the vessel. And KCS Gazebo is the one that will help us combine these together, like the visual aspect and the dynamics aspect together in this KCS Gazebo. I will talk in detail about each of these now. So the KCS description folder currently has this model and URDF, these two subfolders. The model folder is consisting of all the STL files which are imported from Fusion 360, the CAD files. So currently we have a file for rudder, a hull, the hull and the propeller. And these STL files we call them in this URDF file. So in this URDF folder, you see this file KCS base.urdf.zacro. This file will include all of these Fusion CAD these .stl files, and that will describe us how the vessel is supposed to look. So all the geometric aspects also. So where is the rudder with respect to the hull? Where is the propeller with respect to hull? What are the joints between, say, what is the joint at the rudder? What is the joint at the propeller? All these things we will describe in this particular file. Next, we have this KCS Gazebo folder. So this has one subfolder which is of importance to us, the URDF folder, and another folder inside it is the Dynamics folder. So this KCS Gazebo Dynamics plugin, this file is the one that Aditya talked about, the shared library. It will call that shared library, and it will apply the generalized dynamics that we have described and apply it to our KCS vessel. So this is what this file is about. And the KCS gazebo.urdf.zacro, this file is the one that is called in the wave KCS.launch. So launch file is the one that you actually launch, and it will have like almost all the things, like starting from the description of like spawning robots, basically that all those information and the world. This launch file includes all information about that. And this KCS gazebo.urdf.zacro, this file needs to be present in this launch file. We have to call it, and it will be read by the GZ server to simulate the vessel, the physics of the vessel. And this KCS gazebo.zacro, currently we have included this file in the above one. So KCS gazebo.zacro is the one which is actually combining these two. So the URDF description file, the one from the previous slide, and the dynamics description file, the one that you are seeing in the dynamics subfolder. So these two are actually being combined in this file, and they have been calling this together is being called in this KCS gazebo.urdf file. Next, we will see. So this USV Gazebo plugins. This is the one that we have to mainly work on. So it has three main things that we need to work on. So there is the USV Gazebo Dynamics.plugin.cc. So this will describe the hull dynamics and the buoyancy and wave forces.
1 second here. Are you guys, is everybody able to get the repository? Is there anybody who is struggling with that aspect before they go further? Is everybody able to clone the repository on their local desktop and see the files that they are talking about?
Sir, like we are planning to show all of that.
Yeah.
Cloning
Okay,
and
planning to show all of that.
yes,
Yeah.
sir.
Okay, all right.
This is the last slide. After this, we will show that everything.
Okay, all right.
Okay.
So this USB Gazebo Dynamics plugin.cc, this file will describe our models, MMG dynamics, and all those things. So, and the buoyancy and wave forces, all of that is described in this file. So all these .cc files that you are seeing here are the ones that get converted into .so, the way Aditya described it initially. So this USB Gazebo thrust plugin will have the how our propeller should produce the thrust, that information, and the file dynamics one will include how the rudder forces and moments should be there. And in general, all these three files have some commonness. So they all have a load function and an update function. So this load function is something that tells us on which link the on which part of the robot, or say, we have to apply these forces. And the update function is the one that is actually telling Gazebo that this is the amount of force that you have to apply to this link. And there are also some supporting functions which take care of the visual aspects. So if you want to show how much the rudder has rotated, you have to include a function to tell Gazebo that this is how much I want the rudder to be turned. All of these information. So in respective files, we will include those. We'll now show the how the installation procedure for this. I'll stop sharing.
Is my screen visible?
Yes.
So first of all, I will open that required thing. So this is the repository that we are going to follow. So the name of the repository is KCS ROS Gazebo, and see, the branch is noetic dev. So this is currently under development. So we have created this branch and we will work on this only. All the installation instructions are here. So open up your terminal first, and
So you guys can just follow along with you, right?
yeah, yes.
Okay.
This will be installed on your host system. There are also other ways, like in Docker also you can do this. If you want, finally we can tell about that. But currently we will be doing on our host system.
No, let's do it on the host system. My Docker thing is working, but I don't think it's
That will not be required mostly for our
for
development.
our applications. Okay.
Yeah. So simply copy this sudo apt update. This will update all the packages in your system currently. Now I have installed most of this, so some of the things might be different for you. So that's okay. First two steps I have done. So are everybody with me right now?
Yes.
Yes, I'm with you. Yeah.
Yeah, okay. So now we will set up the relevant repositories. We will build the essential packages like CMake, curl, git, and Python 3, all those we will build. So just copy that command and enter. Now I have all of those installed here. So it's showing that it's already the newest version. For you, it might be installing maybe. So just tell me when it is done.
Yeah, looks like I too have it them installed, but I guess some of them might not have.
Yeah, yes. Is it done for everyone? Build essentials.
1 minute, please.
Yeah, okay.
Yeah, done for me.
Okay. So shall I go ahead?
Yes, yes. I think if everybody is done, we'll go ahead. Is there anybody who is not done yet?
It's still at 31%.
Yes, sir. It's still at 10%.
Okay, okay.
Okay. We'll wait. You have to unmute and tell us that that is happening so that we know.
Yeah. Yes. So these are the folders that we were talking about, this cases description, USB Gazebo plugins. Now later we are going to clone all of this and you will see in your host system this all of these folders. This USB Gazebo plugins. It's a SRC folder. So this Dynamics plugin, Thrust plugin, and yeah, we have to include one more, this Foil Dynamics plugin. That is also there.
Aditya, how to check if I have Gazebo or not?
Okay, so I think you can type Gazebo.
On the terminal?
Yeah, on the terminal Gazebo minus version. So if it gives an output, you have Gazebo installed. For me, it's 11.110.1 version available.
Okay.
Gazebo space minus version.
Minus version. Okay.
Yes. Anyways, if you don't have, still we are going to install in this. Means it will automatically get installed in all this.
Yes, I think I have 11.
Okay, so the 11 version is 11th version is only required for this. See here,
Uh,
here it's installed in this.
Okay, even if I have them installed, if I run this command, it will not mess up any of the architecture?
So you have 10 to version 10 in your system.
No, I have 11.
Yeah, we are going to install 11. No, 11.
So it should be fine, right? If I can execute the command.
Yes, it won't have any problem. Yeah, at least that's what I know. It won't cause any problem.
Okay, let's
Multiple
go for
Aditya has tried actually it's deleted and it's called this thing multiple times.
Oh yeah, I forgot to delete this whole thing. Wait. Array. Yeah, see, I have installed it here. I will just remove this. Yes. See, I will remove that.
Yes, sir. For me also it's completed.
Done? Okay, nice.
All right, whoever is lagging behind, please make sure from time to time you tell us so that it is your responsibility to tell us so that we can stop for you. Okay.
Yes.
Otherwise, then it becomes a problem if one has to go through and ask everyone each and every time whether they are caught up or not. So if you're not caught up, just feel free to unmute and say, hey, wait, I have not caught up. And that's fine. All right? Okay.
Sir,
Yes.
I'm not able to find that web page, sir. It's not available.
Oh,
Which page?
this.
Yeah, that one.
I think he is not added in that marine autonomy. Maybe that's why.
That might be it. Okay. You have a GitHub account?
Yeah, I have it.
Give me your GitHub ID.
Sir, I have also not following.
Gangesh, right?
Yes, sir.
You have a GitHub ID?
No, sir, no.
So you might want to create one.
The user ID.
Yes.
My user.
No, you'll have to create one, Gangesh.
Okay, sir.
Go to github.com and then
Yeah.
sign up on it. where I need to add. Okay, interestingly, many people here will not have access. Okay. That's something which we forgot to think about, right?
Yeah.
Okay, never mind. Right now I see Manoranjan, Vishwa, Ashwin, Vallabh, Sanjeev, Aditya and Shadab have access. All others, please send me your GitHub ID in the chat. Okay, I have added Aditya. Adding Saket. Next. Adding Ayush now. Next. Adding Anand now. Next. Adding Shubhankar now. Next. Adding Rishabh now. Alright, is that it or is there anybody else? Anirudh. Anirudh. Okay, I have added Anirudh as well. Is there anybody else I have missed?
Yes, sir. Is creating ID, sir.
Okay. Alright, you create and let me know. Krishna Velu. Alright, added Krishna Velu. Those who have been just added, can you check whether you have access to the repository called KCS ROS Gazebo?
Or you can just click on the link that is there in the chat box. GitHub link.
Yes, sir.
I'm able to access.
Okay, fantastic. Kangesh, are you on Ubuntu or are you on Windows?
Windows, sir.
Then
Yeah.
you have problem. You
Yes.
probably will not be able to follow along.
Yeah. You need Windows Ubuntu 20.04 for this. So
Okay.
you need to dual boot your system with Windows and Ubuntu. So you can boot in your Ubuntu system and then follow this.
So that's fine. You just, you can, because we are recording this video, this will be available later too, for you to follow along later on.
Okay, sir.
Okay? But in any case, create the GitHub ID and send me the GitHub ID.
Yes, sir. I have done with ID.
So put it in the chat box and I'll add you to that repository.
Sir, my username.
Yes. Wait a minute. Your username is username hyphen Gangesh or just Gangesh?
Gangesh K199.
Okay, all right. I think I see so far there are 3 pending members. I think Anirudh and Krishnavelu and Gangesh. You 3 have not yet accepted the invitation to join, which must have been sent to your email address. Anirudh, are you able to access? Anirudh?
Yes, sir, I joined Gangesh.
Okay. I'm asking about Anirudh and Krishnavelu. Krishnavelu, are you able to join? How come Krishnavelu is not here? Oh no, he's here. Yeah. Krishnavelu, are you able to join? Krishnavelu? Can't hear you. Your microphone is too weak. I can barely hear you. No, I can't hear you. You have to go into your email address and accept the invitation. Anirudh, you are the only other one who has not accepted the invitation. Are you there? Is Anirudh there? I see him here. Okay, all right. We'll proceed ahead.
Okay. So we have done first 2 steps. We have updated our system, and then we have set up the relevant repositories and dependencies. Now we have to run this command. This will help us. This command. This will help us to set up our system to accept softwares from this website, packages.ros.org. We just have to copy this, copy it, and run here. The password. So it will be done. Hello, is everyone done with this? Okay.
Yeah, I am done with it.
Okay. Now we have to run a similar command. Okay, I will wait for some more time. Ubuntu 20 is a requirement for this. So if you don't have, don't try right now. There are many tutorials from which you can dual boot your system. You can install Windows and Ubuntu side by side and use anyone you want.
Okay, those of you who are unable, Krishna Velu, you have to accept the invitation to the email address that was sent, linked to your GitHub repository. Only then you will be able to access.
Yes, sir, sure, sir.
Okay, is everybody caught up with Aditya more or less?
We have done up till this command. Okay. Just set up your computer to accept software from packages.ros.org. We have done up till this. So see where you are.
And also I have put in the chat box a link for those who want to dual boot your system with Windows 10 and 20.04. A tutorial.
Don't do this on Windows, it will not work.
This won't work for Windows?
Because all this sudo and all, I think all these commands will be different, right, for Windows.
Correct, correct. No, I put in a tutorial how to do it for how to dual boot your system.
Yeah. Dual boot, yes. After dual boot, you boot into Ubuntu and then do this. On Windows, directly don't try this command. That's what I was telling.
Correct.
Yeah.
Unless until you have installed WSL. But that is a complicated process. We'll leave that for later.
Yes.
Okay, looks like only one person, Anirudh, is the only one who does not have access. Okay, is everybody caught up? Okay, you proceed ahead, Aditya.
Okay. So now we have to run a similar command to accept softwares from this website, packages.osrf foundation. So I will take one command at a time and I will copy paste it here. There are 3 commands, one command at a time. So for me, you can see the output. Take one command at a time. Will be easy.
Okay, I'm caught up with you. What happened? Why you stopped the share?
Oh, the sharing stuff. Is the screen visible now?
Yes.
I mistake the.
Okay, we can go to the next one, I guess.
So now we have to update all these installed packages. So just sudo apt update. Do this.
All right, I'm caught up with you.
Okay. Should I go ahead?
Is anybody not caught up? Everyone is caught up?
Yes, sir.
Okay.
Okay, we will go ahead.
So now for all of this software, we need ROS, Robot Operating System, the Noetic version of Robot Operating System, and Gazebo 11 software. So we will set the environment variables. This variable is Noetic. We want the ROS Noetic version, and we want Gazebo 11. So we will set this as is equal to Gazebo 11, and then we will run this command, this last command. It will install all the uh, packages related to ROS and Gazebo, the required libraries and all will be installed in this last command. I have done this.
So, do I do this even if I have both the packages which are required?
Sir, yes. If you don't have, if you have everything, then I think it is not required. If you have Gazebo and ROS, ROS Noetic you have, right?
Yes, I have ROS, Noetic, and Gazebo.
Gazebo 11, then I think this will not be required. But still, there might be certain.
So, is it better to just enter it and do it?
Yeah, I think see, for example, some ROS Noetic joint state publisher, this package will be required. ROS Noetic RVs, this will be required. Now, in your system, it might be possible that some of this might not be there.
So, I will just execute it.
Yeah, so see, ROS Noetic Velodyne simulator, this might not be there.
Okay.
Everything is there because I have installed it earlier. So I think this will take some time. This will install and download and install all.
Yes. Looks like it is upgrading certain things.
So I think everything, most of the things is there in your system. Just it will upgrade.
Correct. I'll just be back in a second, Aditya. I'll just get some water and come back.
Others, please tell like in what state you are.
Yeah, it is going on.
Okay, okay. It will take some time, I think.
It's running.
All right, looks like it is done upgrading.
Okay, so can we move ahead? Others?
Everybody caught up?
No, sir, it's still going on.
Okay.
Okay.
So first it is installing Gazebo 11, then it is installing this libraries, lib Gazebo 11 developer libraries. Then all these required ROS libraries are installed. Actually, some of these we have like borrowed these commands from this VRX repository, but more or less in future our code, our software will be similar to theirs. So all that is required there might be helpful for us also, might be required for us also.
Okay.
Yeah.
All the second years you're able to get this followed up?
Yes, sir. Yes, sir.
Okay. I still have one pending member. Anirudh, you have not gotten access to the repository? Is he frozen? Maybe? I don't know.
Sir, he is messaging in the chat.
Yes, because you are getting a 404 error, Anirudh, because you have to go into your email address, accept the invitation for the repository, and only then you will be able to access that GitHub page. Shadab finished?
Yes, sir, it is done.
Anirudh, you still have not taken the access to the repository. Did you receive the email? Okay, Aditya, I think you can go ahead to the next step.
Okay, so all the commands that we have run till now, they are just setting up the Gazebo and ROS environment for us. Now we will import our source code for this repository. So we'll start that now. You have to first make a folder using this command, mkdir. So just run this command. So now you can see that folder name KCS Workspace is created here. And in that one SRC folder is created and nothing is there in it still now. Now you have to cd, you have to change your directory to src. So now you are in your src folder. Sir, did you come there?
Not yet. One second. Okay, I am in my SRC folder.
Now we have to just clone the corresponding branch. Now we are in this noetic dev branch in this repository. So you have to just clone this branch. So just run this command git clone -b. So after that you have to add your username. Password. I'll stop sharing for some time.
It will basically create a folder called KCS ROS Gazebo inside the source folder.
Correct, sir. Correct. That's what it will do. I will share my screen again. Is my screen visible now?
Yes.
Okay. So yeah, I will show that folder once again. src. This. So this folder has all the code that has been written till now. And we discussed all of these folders. Not all of this actually. This cases description, cases Gazebo and USB Gazebo plugins we discussed.
Okay.
So in cases, yeah.
Okay.
Yes. Now we have just downloaded all the code. We have to compile this code and then we have to run the simulation. So should I go ahead, sir?
Maybe just give a couple of seconds. Anybody trailing behind? Is anybody trailing behind? Everybody caught up?
Sir, it's asking for a personal access token.
Yeah. So for that, I will show you one thing. So you go to your github.com and go to your settings. Okay.
Yeah.
Then go to developer settings. Go down the last.
Okay.
Then you choose this personal access tokens. Then you go to generate new token and then generate a new token and then copy that and paste it there.
Okay.
So when you create the new token, you can set up what are all the permissions you want to give that token.
Yes.
And you can also actually save that token to your credential manager at a later time so that it doesn't keep asking you on your personal system. You can set that up.
So how to do that?
I don't remember right away. I did it a while ago.
Oh, okay.
But it's called Git Credential Manager or something of that sort.
Okay.
If you Google for it, you can find out how to do it. So that way it doesn't ask you for this one every time. And you ask for Ubuntu, yeah. Git Credential Store, that might be. Yeah. So Stack Overflow, I think that is the one I followed if I'm not wrong.
Stack Overflow.
So most of the troubles which we generally face, Stack Overflow is the global place where you can find the solutions.
Yes. What I have done is I have created one gedit.txt file and I have copied and pasted it there, that token.
Correct. The token you have to keep it handy, but what I did is I also added it to this so that I don't have to It doesn't ask me for the credentials anymore as long as I am logged into my system.
Okay.
From a security point of view, that's not a great thing, but then I am not in charge for cryptocurrency and all such sort of things, so therefore it really doesn't matter here. Okay, is everybody caught up? Guys, if you won't respond, how will we know?
Yes, sir. Yes, sir.
Okay,
Downloading, sir.
it's loading. Something is not done yet.
No, sir. It's downloading a lot of files.
Oh, so you are doing this thing, this sudo apt install Gazebo and all.
Yeah.
Oh, that
No,
you are
not
there.
that one. Not that one.
This
Yeah,
Git-
I did that.
Huh?
Yeah, I did that.
So that one is not yet done, huh? Gazebo installation.
Yes, sir. It's
Okay.
Okay.
ongoing.
Does it show any percentage how much left?
अरे यार
No, sir, it doesn't.
Could I just know who all are still having or who are all still on the installation phase? Who all are on the installation phase? Come on, guys, you can unmute and talk if you're on the installation phase so that we know. So except Anand, everybody is caught up? Yes, no?
Yes, sir.
Others? This is not a classroom for you to suffer in silence. Please. Yes or no, at least you should be able to answer. I've only heard from Rishabh that he has been successful. What about the others?
Sir, it is not taking my ID and password. I generated token, but where should I paste it?
So instead of the password, you put the token.
Okay.
So when instead of asking for it asks for the password, you put the entire token there. Copy and paste it there.
Okay.
Okay, I don't know. There's not much response coming. I'm not quite sure. How many people are actually following along with Aditya on this? The whole exercise is to see that we can set it up on our own systems.
Actually, I have Ubuntu 21.1. So I was like searching the packages, alternative packages for the Noetic Dev one, because that's not there for the 21.1. So
You can install ROS from source in that case. In
I
the
have
ROS,
ROS,
right?
but I'm not finding the Gazebo plugins and all, like the extra Gazebo plugins, the teleop one. Because
Is
like when
Gazebo-
it's the sources, when I add the sources list, right, it uses impish for not impish, yeah, impish for instead of like vocal, and impish is not yet updated in the sources list. So it
Oh.
can't find that package.
Aditya, Gazebo also is version dependent on Ubuntu?
I think it's not, sir.
I
Even
have
Gazebo.
Gazebo, sir, but like I'm not getting the extra packages that we need.
Oh,
Oh, those packages are not coming in.
Yes, sir.
Okay, right.
Yes, sir. So like this joint state publisher robot localization.
Those are all no. Those are all ROS packages, no?
Yes, sir.
yes.
Those ROS packages I'm not
Yeah,
having.
ROS. What you'll have to do is you'll have to install ROS from source.
I have ROS base from source, not source, but like from apt repository.
From apt repository. Okay. No, you will have to install it from source because apt can't do the trick for you. So if you go to ros.org and look at the tutorials for installation, there will be something called ROS from source. Okay, I think he's showing you that.
Yeah.
Okay, he's showing you that installation from source.
I'll put this thing here.
You have to follow along the steps here in order to be able to use ROS Noetic on your 21.04.
One thing, like 21.04 is not the LTS version, right? It is going to expire in just few months, like 4 or 5 months.
Correct.
Yeah, so think about it. Like,
You might want to consider going back to 20.04 because it's a LTS, long-term support will be available for it.
yes.
All right, okay. So in that case, it will take you some time to set these things up. So you will try to pick it up later. I hope the others are following, but I'm not hearing from them. So I'll presume that is an yes. All right, let's go ahead.
Okay. So now you CD to your KCS workspace again.
Okay.
Oh, sorry. First we have to source this. Yeah. Okay. I forgot that. So first we have to source this file, opt ros noetic setup.bash. So in this terminal, this noetic ROS noetic libraries will be available to us for use. So just copy this and paste it here.
You may also consider adding that to your bash RC file if you want to get access immediately.
Yes, sir. I will show that. We have to do one more source, and after that, I will show that also. Now you are in your KCS workspace, so just do this catkin make. Now catkin make will build all your packages, and it will compile this. Let's make.
Please make sure that this command should be executed outside the source folder inside the KCS workspace.
Yeah.
It should not be executed inside the source folder.
Yeah, we are currently in our KCS workspace. Just remember that. And then do catkin make. This will take some time to compile.
It came up with an error, Aditya.
Catkin make.
Yes.
Did you do that source opt ROS noetic?
Yes, I did. It said it is unable to find a package named EMPY.
EMPY.
Yes.
EMPY. Oh.
Maybe I'll just try pip install EMPY. It's a Python package and it looks like my base repository doesn't have it.
EMPY.
Oh, it's already satisfied. Then why did this fail?
When running catkin build, I get the following error. Yes.
Oh, it says that this can be solved by telling it to use Python 3. That is probably why it's not doing it. Okay, I'll do that. One second, let me see. Is that 7M? I'm not sure that I understand that. User bin, no, user include Python 3. Oh, it should be Python 3.8. There are two folders actually. There is Python 3.8b and Python 3.8. I don't know which one should I be using. Using the Python 3.8. Okay, it seems to be proceeding now. Looks like Aditya is having a low bandwidth for some reason.
Sir, his laptop has freezed.
Okay, but his trick did work. So instead of, we were using catkin make, the same process works with catkin make as well. So you can say catkin underscore make followed by all that b python executable slash user slash bin slash python 3 and d python include directory slash user slash include slash python 3 point whatever version you have. So what I did in my case is I just tried to go to that directory slash user slash include and check which version of Python directory I have there, and I just put that folder's name in the dpython include directory. For those of you who are stuck like me. I guess Aditya has left somehow.
Yes, sir, his laptop was freezed.
Oh, okay.
Maybe I will share his link. Now he's rebooting.
Okay. So everybody has finished catkin make. Those who are able to follow along. Come Come on, guys. Is a yes or a no? Is it really that hard to expect?
Sir, what was it, sir?
Yes, sir. We are running the Gazebo simulation as well.
You're able to run the catkin make and all that is over. You have actually even proceeded further.
Yes, sir. Yes, sir.
Okay, all right. So let's do that, Vallabh. So you have to source the KCS workspace. Well, setup not match.
I think there is one extra space that has come over there.
Oh, there's an extra space there? Okay. But that doesn't bother us, right? Ego.
Okay. Sir, were you able to solve the problem?
Yes, I was able to solve it. I had to point it to my Python 3 installation. What it was doing was it was looking at my Python 2 installation.
Okay, okay.
Okay, but now I have run into another problem. I am not able to start it off, Vallabh.
Sir, which command did you run final?
The ROS launch command, it failed, saying that no module named ROS package, ROS PKG.
Okay, so sir, are you using Anaconda on your system?
I am.
Oh, so that's
You will have to like comment out from the bash RC. You have to comment out the conda related term.
yeah, like
Oh.
I think I will share my screen and show you what all you need to comment.
Okay.
I don't.
Yeah, I think he doesn't have Anaconda. I have that, so I had the similar problem. I will show you. So, sir, are you able to see my screen?
Yes, I can see your screen.
Okay, so you need to open your bash RC.
Correct. You will need to do sudo, right? Otherwise, it won't open.
No, sir. Just do gedit this bash RC.
Okay. All right.
So now, at the last, you will have certain lines written related to Anaconda.
Correct. Conda initialize. I see that exact comment in mine too.
So just comment out all of this. All of this. Comment out.
How did you comment it out?
Okay, you are doing using gedit, no? Do you have VS Code?
No, I don't have VS Code.
Oh, then I think you have to do manually.
I do manually. Oh.
on VS Code, just you do control// all will be commented.
Correct. That is what I was hoping to do, but it didn't work.
Yeah, it will not work here.
Otherwise, I should open it in a different editor, I guess. Okay. Done.
Okay, done.
Out, save it.
Sir, you have these lines in your bash RC, right? Source opt ROS noetic and source KCS workspace devel setup.
Yes, I have sourced them now, but I did not add the KCS devel version.
Okay, yeah, just add this line also.
Okay. I generally don't like to source that ROS thing because it will mess up the conda environments generally.
It is not actually like needed, right? If in particular terminal you just source.
Yeah, that's what I usually do. So that's
okay. Yeah.
I'll stick to my old school habits.
Okay, that is also okay.
Right.
So after doing that, then just do source bash RC.
Source not bash RC.
Sir, before your terminal might have some base here, right? Base.
Correct. Now that is gone. Correct.
So yeah, so that's correct. Now you close your terminal and open a new terminal, and then
Okay.
then again do source bash rc, and then I think run that ROS launch.
Okay. Now when I open the new terminal also, that base thing is gone.
Yeah, so because we did it in the bash rc, we commented out that lines. That's why
Correct.
it's gone from there.
Okay. All right. I sourced it. Now let me try running the ROS launch command. Oh, when you made me close my terminal, I have to source ROS again.
Yes, yeah, you have to source that again. Oh, it's not here. Why? What? What happened? Oh, I think that catkin make was not done properly for me. That's why maybe.
Should the second source command be executed outside the repo or inside it?
Inside the workspace.
Okay.
KCS
No,
workspace.
source command you can do from anywhere. That's not the problem because
Maybe,
you.
level setup. Right? Okay, yeah, the latter one also can be actually done because we are including.
Yeah, because you are giving the whole thing, no? Whole.
Okay.
Okay, I see the ship heaving.
Yeah, so yes.
But why is it heaving so much?
Sir, all the dynamics and all is not properly tuned for KCS till now.
So, but I'm just curious, why does it keep moving up and down? Why does it keep bobbing? Oh, no damping. That's why. Eh?
Like for me, it was not moving like.
But I will.
It was not. For me, it is. It has been moving since I loaded it in. Continues to heave up and down.
I'm getting something like RL exception.
RL exception.
Yes, sir.
On the terminal in which you are running the launch file?
Yes, sir.
Interesting. Maybe what we can do is after Aditya has successfully run it, we can ask you to share your screen and then try to figure out where the problem is.
Aditya, wave Gazebo.
Oh, that's what. Now it's here. So, what was the problem you were telling? Like,
It keeps heaving up and down.
okay.
Yeah, like buoyancy that we saw yesterday, right? That the buoyancy is actually for the catamaran vessel, and that
Ah.
you
Sir,
applied.
yesterday we saw, right, the buoyancy that they were calculating was for that catamaran hull. Same thing we are using here. Like, we haven't changed anything in that.
Correct, but why wouldn't it stabilize even with the catamaran hull? It should stabilize at some point, right? I would expect it to at least.
Okay, so that's why you are saying damping. Okay.
Yeah, I have a suspicion that the damping might be low.
Yeah, it is continuously doing this motion.
In the meantime, can you help out Saket?
Yeah, I will stop sharing.
Saket, can you share your screen?
Yes, sir. Are you able to see it, sir?
Yes.
Yes, we can see your screen.
Oh, it's coming like this.
Wave KCS.launch is neither a launch file in a package, nor is Wave Gazebo a launch file. Did you source this one?
So actually, his catkin make is not like it is. It's very small, right? The output should be large. Like
Yes. Can you ls into this folder?
just to catkin make once again, maybe catkin make.
Uh,
Oh.
like the
No. Can you do ls in this? Just type ls. cd source, cd src, and then ls. No, not src. Go into that folder. Yeah. Press enter. Now
Oh,
do
he has, I think, cloned a different branch, wrong branch, maybe because there
yeah.
is nothing in SRC.
Yeah. Can you say ls in this? Yeah, there's nothing here. See?
Hmm.
So here is where you have to clone that repository.
Yeah, just go to that readme.md file and copy that git clone -b command and paste it here.
Go to that website. Yeah.
So,
This command, just copy that and paste it there.
scroll down.
Yes.
Okay. You might want to unshare your screen at this current time.
yes, 1 second.
Otherwise, your personal access token will become a public access token. Okay, its amplitude has... No, it has not decreased. It's still moving up and down with the same amplitude.
So there are parameters that we have to change in this.
No, but I'm wondering why that is happening. Is there a wave here? Actually, is there an ongoing wave?
Yeah, like we have used the PM spectrum thing.
Oh, so this is actually the response in wave.
Yes.
Oh, okay. All right. Then it makes sense that it is doing something. It should be, right? But I don't see any of the waves on the surface.
Like their mesh, the surface, sea surface that we are seeing is actually like a mesh, and on that what we were seeing yesterday, like they apply that PM spectrum and get those heights at different points.
No, but the visualization for the wave itself is not there, no?
Yeah, like maybe they are not actually making it that mesh move.
Oh, okay. In that sense, you mean, okay.
So also, and there is one another problem. Like if you drag this vessel up into air and leave it from there, so it has to free fall under gravity, right? But here, if you do that, you will see that there is some problem. It will very slowly, it will come down.
Oh, is it? So I can
Yes.
actually hold the vessel and drag it
Yeah.
up?
Just press T. Just press T. Then
Like the
click on
coordinates
the
will come.
Oh,
click on
yeah.
the
No, wait a minute. When I pressed T,
No, click on the vessel. There will be a bounding box around it.
oh, I have to press T and then click on the vessel. Okay.
No, like first click on the vessel. A bounding box will come,
Okay. Yes.
and then press T,
Press T.
and
Okay.
then
Now the coordinate system appeared.
and then like on the red one, maybe you can just drag it up.
choose that vertical axis and then take it up.
Oh, okay. All right. Oh, it slowly comes down. Huh?
Yeah, that
Yeah.
should not happen.
It should like
But maybe that's because gravity is, the visualization is scaled in some sense, maybe?
The mass matrix is not defined according to the vessel, right? It's for the. It's still for the catamaran.
No,
But
like
still,
it's
acceleration
completely random.
acceleration due to gravity must be there, no? Like total g.
I guess it must be acting. I mean, the visualization parameters may be scaled or the time may be scaled.
Yeah, the simulation time may give you an answer. How much is the simulation time? How fast it is?
So what is the ratio between your simulation time and real time? On the bottom of Gazebo screen, you will see that
Oh, and the bottom of the Gazebo screen.
ratio.
Factor, real time factor is 1.
So
And
real time and simulated time, they are both the same.
So the ship should fall down quickly,
Yes.
but it is not. Okay. It's funny. So, am I to understand that if I can I close this for now?
Yes, just press Control C in your terminal.
Control C in my terminal. Okay, all right. So my question is, I want to do something interesting and funny. I want to increase the mass and then see whether that thing sinks or not.
We can try that.
I'm on for all these sorts of crazy things.
If the current mass is like, if you increase it 10 times, it sinks. Like,
It should definitely sink, right? If I increase it 10 times.
yeah, it is happening. Like,
Okay, so how do I change that?
maybe you can share the screen.
Shall I share my screen? Okay. Screen. Okay, share. Is my screen visible?
Yes.
Okay, I am inside KCS Workspace, ROS Gazebo.
In the KCS description,
KCS description.
URDF.
URDF.
This.
I open this with a text file.
Now the hull link, inertial, line 47.
Line 47, mass value, it is 11.8.
Yes.
So I can simply make it 110.8.
Yes.
And I save this.
Yes.
Close it, and then I go back and do my Gazebo again.
Yes.
And this time I should see the vessel sink. It's not.
Like, it is synced more. Like,
The draft is decreased.
No, but it should sink. It should completely sink and disappear, right?
Like, this might be exactly like, actually the way we have applied the buoyancy is like wrong.
So let me go ahead and can I just change the URDF file from here and will that update automatically?
No, sir. Here it will not happen. No. You have to close this first. This simulation. You have to close this simulation.
And then only I can do that, huh?
Yes.
So if the mass value is...
Sir, make it to 1100.
Yeah, that's what I have to increase another 0 in it. Okay. So now I have to stop this simulation.
Yeah. Stop the simulation and run it again.
It's quite a bit of time it takes to close down.
Yes.
All right. Okay. Launch.
Yes. You can actually also see it falling down if you go in the left tab. In this KCS 0.
KCS 0.
Yes. If you like on the KCS 0 base link, if you go,
okay,
and right click on it.
Right click on it.
Follow.
Follow.
Yeah. Now it's like you are actually following it falling down.
Oh, it doesn't have a base where it is stopping.
No.
Oh,
it will fall down infinitely.
It's like that song, huh? So I'm actually free falling.
Yes.
Okay. And basically the wave's water surface is long gone.
Yes.
Yes.
Okay. Is there a way to start this thing to not fall from zero level but at a higher height so that when I
Yes.
start the gazebo simulation I can see
Yes.
it fall down?
Yes.
Actually, you can even start it at pause moment. So you can run the play button and then you can see everything happening.
Oh, how to do that?
So
Maybe you have to close on this one.
yeah, just close this simulation.
All right.
Actually, both these things can be done in the same file, like pausing and like starting it from a height.
Hmm. Okay, so
Now we have to go to KCS ROS Gazebo.
KCS ROS Gazebo,
This wave Gazebo.
Wave Gazebo,
Launch.
launch,
Wave KCS dot launch.
Wave KCS dot launch. Okay.
In this Z arc name Z that you see, default is 0.5 on line 13. Yeah, if you put it maybe 1 or 2 meters maybe.
So it's say 10 meters, 10.5 meters.
Okay.
So 10.5 will take time to come down because
Yeah.
our gravity is.
Yeah, it will take a lot of time.
Oh.
Maybe 3 meters say.
Say 3.5 meters. Okay.
And then this paused fourth line.
Fourth line. Fourth line. Okay. Pause.
Paused default you put true.
True. Okay. So I save this.
Yes, and start.
Close it, and I start it again.
Yes.
Right.
Now it will be in pause.
It's in sky. So
I start it.
yeah.
No sir. Now you zoom in a bit and then then click on the play button below.
At the bottom near the real time factor.
Okay. Let me first find a nice view for it.
Yeah.
You can. Yeah.
Yeah, that's perfect. Okay. Now I simply play here.
Yes.
Whoops! It's gone.
Yeah, like the mass we kept at.
No, but how does mass change the acceleration? Mass should not change the acceleration.
Yes, that's what mass will check, right?
That's why it dropped down, right?
No, it would define gravity. Previously, it fell down slowly, no?
Yes.
Okay. Slower, yeah.
It should be independent, right, of that
No,
mass.
maybe that is because your computing speed and my computing speed is different. So we should really see if I put it at with the old mass and I put it at the same point, does it still fall down as slowly or as quickly?
Yeah.
All right, let's see that. Okay.
If that is not epic, then maybe it's the something is
Really wrong. Then the physics is wrong. Okay, I need to go into URDF file, change the mass back to its original value, 11.8. Right. Okay, so now it should disappear equally quickly. See, there is something wrong with the physics. Clearly, this is not doing what it was supposed to be doing.
Yes.
But
how is it possible? Like
now it should float.
The gravity has become mass dependent.
Yeah, the acceleration with which it is floating has become mass dependent. Probably somewhere you have messed up, or they have messed up.
No, sir, it will be
maybe we messed up. Like Bambi doesn't do this.
Yeah, I have checked with Bambi. It falls properly, like.
Okay, so somewhere the physics is off. We have to figure out where it is. Here I can see the wave surface is moving actually.
So it should oscillate, right? It's continuously.
Then it should oscillate. So that seems to be right. Does it? Is it also drifting?
No.
No.
Like we can't like.
No, is it shifting to the left on my screen is my question. No, I don't think so. No, I don't think so. I think it's still there only. Yeah, I think it's there only. Okay, all right. That settles one issue for us. Okay, thank you for telling me how to do that. But clearly, the physics is not right. We now understand that, right? Okay, fantastic.
Someone had a problem, right? The cat can make an on Saket, right?
Saket, yeah.
Did you?
Yeah, I can get the simulation.
Okay, nice.
Actually, how to zoom in this? I'm not sure.
Scroll your mouse middle. Text.
Okay, sure. Touch.
And if you hold the scroll button down, you can rotate your view.
Okay, sir.
Like if you press shift and the mouse button, then you can change the camera's view. Hold down shift and left mouse button and move it.
Tell me again, Vallabh. Hold down shift and
hold down shift and left mouse button.
Okay. Oh, that also does the same thing. Okay.
Yeah.
And even you can do that control and left mouse button. That will not rotate. That will just shift, slide, translate.
That will be like a pan.
Yeah, pan.
Okay, interesting. Okay, so good. Now we have to populate this with the physics. That would be the next step, right?
We have to write that plugins properly.
Correct. So I understand that there are 3 teams as per what you were telling me yesterday.
Yes.
So who are in the 3 teams?
Me and Aditya, we are working on the thruster bar. Manoranjan and Sanjeev are working on the rudder bar. And Krishnavelu are working on the hull.
Ashwin and Krishnavelu.
Yes.
Okay, hull. Okay.
But now, like, hull's problem has increased more. Like the buoyancy, it is completely wrong.
Somehow feel that that's a problem. I don't know how is the mass changing the. Is there as it falls through the fluid, is there a drag which is acting on it? Does it reach some sort of a terminal velocity?
Definitely, maybe like in the code there is no such provision. Like the buoyancy is actually acting only on the surface that we saw.
No, buoyancy is. I am talking not. So when it is free falling through the air, there is no buoyancy there. But there is a drag though.
So maybe the object is falling with terminal velocity, like as if it's released from space instead of from that height.
Correct. So if we change the damping value to be 0, then they should both fall off at the same speed. Right? Right now there must be some damping in the heave direction. Z value will be there. I suspect it will be there in that. Where will this be? In that file has to be there, no? That plugin file you guys showed me yesterday. Where is that? USB Gazebo plugins.
Yeah.
Source.
Yeah.
And USB Gazebo Dynamics plugin.
Yes.
Okay, so if I look here, there should be hydrodynamic parameters, added mass, damping matrix. There is actually a quadratic damping in Z. Actually, there is a quadratic damping in all modes. That is why it will reach a terminal velocity. Maybe I'm not sharing my screen, am I? No.
Maybe we can plot the view velocity and then the vertical direction velocity, and then we can see. In Gazebo, we can do that actually.
Oh, is it?
Yes, like we can do real-time plot of our model.
Okay, how do I do that?
So first you have to launch your simulation, and then like I have to see that I forgot it.
Yeah, I have already launched my simulation.
Then yes, can you share that? Camera view window. So in the right side, right top, there are four. This thing, no, four.
View.
No, right, top right.
4 icons, sir. One
Four
showing the
icons.
statistics graph and camera.
Yeah. So just wait, hover on that. Create plot. Yeah.
Create plot. Okay.
Now wait here models. Go to models. KCS 0. Velocity.
Oh.
Then linear velocity.
So I can simply plot position. No?
Position. Yeah, it's okay.
How to add this? Nothing is.
Just drag it. Drag it. I think.
Oh, drag it in.
Currently, it's just doing this. This is
No.
a real-time plot of.
Oh wow, it's amazing.
Yeah. You can even do with. It's all possible parameters. You can do that.
Now, can I? Previously, you showed me how to pull this thing out of the air, right?
I just click on that vessel, then press T.
T.
And then on that blue arrow, just drag it up, and then escape.
Hey, leave.
Leave. Yeah, you can see the velocity. Oh, sorry, Z.
It is falling at a linear velocity.
Yeah, this should not happen.
Yeah, it should not happen.
Yeah, like as you were saying, like the terminal velocities are already reached.
Yeah, because of the quadratic damping and other things, it is attaining terminal velocity.
Yeah, the Z velocity is constant only.
Correct. That's what. Yeah, interesting. I really like this. This is much nicer. There are a lot of things you can do. Once you put the physics into it, wow, it will be a fantastic place to play around with this.
Yes.
Wow. Okay.
Now, these topics are there, no sir? This KCS 0, world position, position. So we can subscribe to any particular topic and then we can extract all the data that we want.
Oh, okay. So right now, if I look at a new terminal,
New terminal, and then there if you do ROS topic echo.
list.
List will list all.
Yeah.
Oh.
So these are all the topics. So I would say that I need model states, right? Let's topic echo, or let's say let's topic info. Go.
I thought this should be possible.
Publisher is Gazebo. Okay, right. So it's okay. It doesn't say what message it is publishing. Usually info should give that. Okay, this is the twist.
So what did you echo right now?
I did what you call
model states.
Model states, okay.
Model states. Okay. Model states. That's what I echoed. So it is giving us linear and angular velocities. What else is it giving? Position. How come the position is not changing? Oh, that is the pose. It's only the second one fellow's position that is changing.
This is I think both the base link and the KCS 0.
Okay. Ocean waves, nothing is changing. See,
ocean
waves position is not changing.
Yeah.
But the KCS 0, the position is changing, orientation is changing. You have a quaternion which is being coming out, and then you have the linear and the angular velocities. Oh, fantastic.
In this Gazebo plotting utility, is it the quaternion?
It is?
Is it quaternion in this Gazebo?
Yeah, there will be quaternion here, orientation, under orientation it will be there.
No.
The lead is converting it maybe.
Yeah, it's converting roll pitch out.
Pose is in roll pitch and yaw. Okay. So therefore in here we should see something happen in the pitch. How do I remove these?
You can just, I think, yeah. Sir, can you zoom in a bit? Like it's very small. Let me see.
Zoom in this plot.
Yeah. Yeah.
It is slightly increasing and
It's really not doing much. It's very small.
Yes.
But can I adjust the values on this side? Maybe I can do that. Clear all fields. Clear.
It will clear all that.
Yeah. So now bring pitch and just put it there. There you go.
Now the scale is proper.
Yeah. So it is running off of some wave model, but those waves we can't see. Okay, here they had something else also. I thought I saw set link also, set link state. Wonder what it is. Set model state. Yeah, I guess we'll have to figure this out. ROS topic echo. State. Nothing will be here, but if we nothing will be here. If we publish to this, we can make it do some funny things, but I don't know how to do it. Not yet, at least.
What is this set model state? Like, can we apply some forces or
yeah, we should be able to apply some forces if you want, or some kinematics, I guess.
If you click on the model,
okay,
and like right click, there is that apply force dot thing. Like I haven't seen it actually make any changes on it, but
I think we were applying to the wrong link or something.
Yes. Let's say I apply 100 newtons. Apply force. Wow, it did something. This graph is changing.
Yeah. Sir, can you plot that roll graph?
Huh?
Can you plot that roll graph? Because you are applying a torque.
I'm applying a torque. No, I'm applying a force actually.
Okay.
I'm applying a force in surge. So maybe what I should do is get rid of this thing, clear all the fields, and then bring the position in X, and then apply this. It will be fun to see. Apply force. Wow. So it is actually it's like an impulse response function of that. But can I have wave to be set to be 0 in this case? Can I set the wave to be 0 somehow?
Yeah, like we don't call the in that wave KCS.launch if we don't call the wave one.
No, but something is happening, which is why it is doing this, right? Some environment is playing around.
Yeah, like if we not call the ocean wave one world.
Oh, you mean to say, suppose if I close this and relaunch it with a different launch file? Okay. But then I am still surprised how it is getting a restoring force in surge. It should not be, no?
Yes. Currently, it's kind of like fixed in the space at that point.
No. What I mean is this. See, if I look at model KCS 0, acceleration pose, position X. Say, let's say I'm plotting X, okay? And then I'm following your approach of adding a 100 Newton torque or force suddenly. Then what should happen? Even this vessel should move.
Yeah. Yeah. Currently, in like the base link, I think like I'm not sure exactly what is happening.
Sir.
That base link is fixed with respect to this world, this the entire ocean surface.
No, but it is oscillating, which means it's getting a stiffness force from somewhere in the surge, which is surprising.
Sir, can you do one thing? Like apply to the link in that you can select the hull link.
I did apply to the base link, no? One is base link, propeller and rudder. So let's say if I apply to the rudder, 100 newtons I apply, still I'm seeing funny things happening. The physics is not right. We have to understand this physics part correctly. Because I would assume that when I apply a force, it should actually move because there is nothing to stop it. But here it seems like it has a restoring force which is pulling it back.
Yes.
Whereas we know that in surge there should be no restoring. See, for example, if I
Currently, we didn't change any of the physics, right? That physics is coming from that VRX part only.
correct. So when I apply this in Z, so let us say I take this off. Set plot at Z. Then I apply the force. See, when I apply the force in Z, nothing is happening. Ooh. How come? There's no change. Because that force is too small. Yeah, see, you now see something happening. No, but why is Z going in sideways direction? Hey, something is off. Where is my axis system? X is the R, right? And Y is the up. Okay, so I should be applying force in Y. Sway would be the green. So right now I'm applying force in sway. That's why it's doing that sideways thing. But then it is coming back so quickly. What is causing it to come back in the physics?
Like it's as if like there is a spring.
Yeah, as if there is a very, very strong spring attached to it, that it is bringing it back. Wow. So if I apply in Z, what happens? Just curious. Oh, sorry, in the vertical direction. So in Y, I apply. And I don't apply on the rudder, but I apply on the base link. Let's say apply force.
So it is showing direction also, right? In which direction it is applying.
Yes.
So you are applying in horizontal only till now. Means right now also.
Oh, the Y for the rudder was different. Oh, see? Okay, that is what was different. I think I messed that up. So if I apply Z, yeah, now it is applying up and down.
So apply huge force like for 1000 or something. Oh.
It's still going sideways. Why?
It should pitch right now. Yes.
Yeah, I would have guessed it should do that. Somehow this physics is what we have to understand. Somehow we are not understanding that properly.
I'm thinking that even the KCS description needs to change now, like that.
Possibly, it is possible. But thank you for showing this. I think this has been a terrific one. Maybe we should stop recording at this point, unless until anybody else has any questions to ask. Any other queries from others? Was everybody able to run it?
Yes, sir.
Yes, sir.
So now the problem is simplified. They have made it easy for us. At least they have made it easy for me. And I'm not seeing many people's faces. Can I please see faces, please? I'm telling you, the moment we stop this lockdown thing, I'm going to call all of you in person. No more hiding behind a screen. All right, but I think Aditya and Vallabh have done a terrific job. Please let us congratulate them for this, because it has made the learning curve to start exploring Gazebo much, much shallower. So it is allowing us now to quickly start exploring. Now we can try implementing physics in it, changing the physics in it, and seeing what happens, at least the base platform they have given us. In fact, I have feelings that we can in fact even integrate Hydra together with this in order to make it to be even better. I think that's a wonderful.
So that last part that Aditya showed about the plots, right?
Yeah.
It will be much more interesting to see those plots with Hydra's like physics.
Correct. So to see do parametric roll and then compare it with an actual video of the thing which we have measured during experiments would be fantastic. I mean, that would just blow me out of the world. That's all. Right. So it would be really nice to get to see these things and get it up to speed. Okay, let me stop recording here.